The universe is unimaginably vast, filled with billions of galaxies, trillions of stars, and countless planets. So how is it possible that we haven't made contact with even a single alien civilization? The silence is deafening and fascinating. In 1950, during a casual lunchtime conversation, the brilliant physicist Enrico Fermi asked a simple yet profound question. Where is everybody? This question, now famously known as the Fermi Paradox, highlights the puzzling contradiction between the high probability of extraterrestrial life and the total absence of any evidence for it. In this video, we're diving deep into one of the most thought-provoking questions of our time. We'll explore the possibilities, theories, and implications of why aliens haven't contacted us, or why we haven't found them yet. From the idea that life is extraordinarily rare to the chilling concept of a great filter, the answers may be stranger and more unsettling than you think. Stick around and let's unravel the mystery together. Let's start by putting things into perspective. Our universe is home to an estimated 2 trillion galaxies. Each galaxy, like our Milky Way, contains hundreds of billions of stars, many of which host planets within their habitable zones, the regions where conditions might allow liquid water and, potentially, life. In 1961, astrophysicist Frank Drake devised an equation to estimate the number of detectable alien civilizations in our galaxy. While the exact numbers depend on a lot of assumptions, even the most conservative estimates suggest there should be thousands, if not millions, of civilizations capable of communication. So, where are they? On a smaller scale, consider this. Earth developed life relatively early in its history. If similar processes happened elsewhere, intelligent life could have emerged billions of years before us, giving them a massive head start in developing technology and exploring the cosmos. One of the most compelling explanations for the Fermi Paradox is the rare Earth hypothesis. This theory suggests that complex, intelligent life might be incredibly rare, possibly unique to Earth. Think about it. Earth's conditions are a perfect storm of factors. Our planet orbits within the Sun's habitable zone, has a stable climate, a protective magnetic field, and liquid water. Add to that the role of the Moon in stabilizing our axial tilt, and Jupiter's role in deflecting dangerous asteroids. Could this combination be a 1 in a billion coincidence? Even within the Milky Way, many stars are more unstable than our Sun. High radiation levels, extreme solar flares, or the lack of heavy elements in certain star systems could make it impossible for life to thrive elsewhere. If these conditions are as rare as some scientists suggest, it might explain why we haven't heard from anyone else. Let's delve into one of the most intriguing and unsettling concepts surrounding the Fermi Paradox. The Great Filter Theory. This idea suggests that at some point in the process of life's development, there's an insurmountable barrier that prevents civilizations from advancing far enough to explore the galaxy. The Great Filter could lie behind us, or ahead of us. If it's behind us, it might mean that developing intelligent life from simple organisms is extremely unlikely. Perhaps Earth is among the very few planets to have passed this stage. But if the Great Filter is ahead of us, it could represent catastrophic events or self-destructive tendencies that most advanced civilizations cannot avoid. Think nuclear wars, climate collapse, or runaway AI. If the Great Filter is behind us, we might truly be alone, but that's good news. If it's ahead of us, it implies our chances of long-term survival as a species are slim. Could it be that we're not hearing from extraterrestrial civilizations because we're searching the wrong way? Traditional methods focus on detecting radio signals or optical communications. But what if advanced civilizations use technology beyond our comprehension? Our search assumes that alien civilizations would communicate in ways similar to us. But imagine trying to explain the internet to someone from the 1800s. It's possible we're dealing with a similar gap in understanding. Some scientists suggest we should look for technosignatures, evidence of advanced technologies, such as megastructures like Dyson spheres that harvest energy from stars. These could emit detectable heat or light patterns, Others propose searching for anomalies in quantum fields or gravitational waves as potential signs of intelligent activity. Another angle to consider: what if extraterrestrial civilizations are deliberately avoiding contact? They might fear interference or view us as too primitive to engage with. The lack of response might be intentional, a form of interstellar isolationism. Here's a fascinating and mind-bending concept that ties into the Fermi Paradox: the simulation hypothesis. What if we, and everything around us, are living in a highly advanced simulation created by an intelligent civilization? The theory was popularized by philosopher Nick Bostrom, who argued that one of three things must be true. Advanced civilizations tend to go extinct before they develop the technology to create simulations. Advanced civilizations are uninterested in running simulations of their past. We're living in a simulation created by a future civilization. If we're living in a simulated reality, it might explain why we don't see other civilizations. Perhaps the creators of our simulation have restricted contact with other simulated worlds, or perhaps they simply haven't programmed alien civilizations into our reality. In essence, they may have designed a universe where we are isolated to make the simulation more manageable or to test the development of intelligent life. The idea is unsettling, but intriguing. If the simulation hypothesis holds any truth, it opens up new possibilities for understanding not just the Fermi Paradox, but the very nature of our existence. Are we really alone, or are we part of a grand experiment by an alien intelligence? We've explored a multitude of theories today, from the idea that extraterrestrial civilizations could be hiding in plain sight, to the chilling possibility that we might be living in a simulation. The Fermi Paradox continues to challenge our understanding of the cosmos, pushing us to think beyond our conventional limits. Ultimately, we still don't know the answers to these questions. But one thing is clear: the search for life beyond Earth is far from over. Whether we're dealing with missing signals, an advanced civilization hiding from us, or a simulation designed to study us, the truth could be even stranger than we imagine. Keep questioning, stay curious, and who knows, maybe one day we'll crack the mystery of the Fermi Paradox. If you enjoyed this dive into the unknown, don't forget to like, comment, and subscribe for more explorations into the mysteries of the universe. And as always, keep your eyes on the stars.